This video actually puts together chapter 4, sections 1, 2, and 3, which are transformations. So it kind of is briefer than if we had separated them out on their own, and it kind of just goes over the basics of all these different transformations. So first of all, what's the difference between a rigid and a non-rigid transformation? And what's the definition of a transformation at all? So a transformation is a function that moves or changes a figure in some way to produce a new figure. So you'll have two figures. One is called the image, which is the new figure, so the updated, what has changed. And the original is called the pre-image. So think pre comes before. So the pre-image would happen before the image. A rigid motion or a non-rigid motion are both ways to change. They're both transformations, so they're both a way to change these images. And a rigid motion doesn't change the size of the shape. So the original shape will have the same size when it is done into its image. A non-rigid motion changes the size or the dimensions of the shape. So this is a shape that's going to then get bigger or smaller. That would be non-rigid. Think rigid means like fixed. So that helps me remember that means it didn't change its size. There are 3 different types of rigid motions. Again, not changing a size. The first is a translation, and a translation is also known as a slide. So you're literally taking your pre-image and you're sliding it in a direction. When you're looking at an image, the pre-image will have normal letters. So this would be triangle ABC. And the pre-image is going to have these little tick marks after the letters, A prime, B prime, and C prime. And that means that that's the image. So that's the one that has been changed. So blue, pre-image, red image. In this translation, there's a slide to the right and down. So this is both vertical and horizontal. If you compare just one individual point here and you wanted to know what the change was, you went to the right 1, 2, 3, 4, 5, and you went down 1. And so the way we show that is that the X changed by going to the right 5, which means it would get added 5. And the Y changed by going down 1, so the Y would get subtracted. Or 1 would be subtracted from the Y. And that's how you would change show the change in a translation. If you did the same thing with B or C, it would all be the same. All of them are to the right 5 and then down 1. A reflection, if you think about a reflection, proper reflective property, or a reflection you looking at your mirror, it reflects in a way in which it goes over something. So it's duplicated or spun over a line, and it could be a horizontal line, a vertical line, it could be a diagonal line. But it uses a line like a mirror to reflect it over it. The mirror line is called the line of reflection. So in the image that's here, the pre-image, again, is your regular letters, so A, B, C. And the image is the red, or A prime, B prime, C prime. And it was reflected over this line. So this line of reflection, which in this case is Y equals 1, because it's a horizontal line that runs through 1. So we would say that all of those points were reflected over Y equals 1. To find the new points, you're going to count the same distance away from the line of reflection. So if I had just the blue line, or the pre-image first, and I wanted to know where the image is, and I knew that this was my reflection line, then I would count the same distance away from that line as the current coordinate is. So A is up here, and it is 2 units away from the line, which means I'd go 2 units away from the line in the other direction. B is 1 unit above the line. I'd go 1 unit below the line. And then C is actually on the line, so it stays on the line. And that's how you get your image. There are actually coordinate rules for reflections for specific reflections. So if it is said that A, B, or a coordinate point or whatever is reflected over the x-axis, then we take its coordinate point and change the sign on the y coordinate. So notice the A stayed the sign, which would be the x coordinate, but the y we change the sign on. That's when it's reflected over the x-axis. When it's reflected over the y-axis, we're going from left to right. So we're changing our x to negative x. If it's reflected on the line that is y equals x, that means that the y-intercept is at 0 and your slope is 1. So the y equals x line looks like this. And in this case, we would switch the x and y. So where this would give me 2, 2, if I wanted to reflect it over it, I'd switch the value. So if my coordinate point was down here, let's just say at 2, 0, then the image would switch to be at 0, 2. So you would switch the x and y. Again, y equals x, switch x and y. And lastly, if it's reflected on the line y equals negative x, now the same idea to start. You have a y-intercept at 0, but you're going to the right and down one this time. The y equals x line would look like this. And so we switch the order and we also change its signs. So if you want, make a note of this or make a quick screenshot of this because it will be really helpful when we get to our examples. And the last non-rigid transformation is a rotation. These are rotated around a fixed point. So if you could imagine taking an object and spinning it clockwise or counterclockwise. Notice this picture here. So this is your pre-image. It was spun to the counterclockwise direction, and it ends here. So this little arrow is telling you which direction it went. That's your counterclockwise rotation. And here are also some quick references. If it's a rotation of 90 degrees, then we switch the coordinates and change the sign of the new x, which was previously the y. For a rotation of 180 degrees, we switch both signs. And for a rotation of 260 degrees, we switch both and we change the sign on the new y, which was previously the x. All right, so really we just want to be able to identify the translation and write the rule for the translation. So for the first one, you want to look at your pre-image, which is the blue, and your post-image, or your image, sorry, which is the red, and see what happened here. If you're looking at 1, it was reflected over the y-axis. So this point flipped over to become here, this to here, and this to here. So this is a reflection. And it's over the y-axis. If I were to look at the coordinate points, my A, which was -2, -1, reflected over here to be +2, -1. So the the y value, I was right the first time, sorry, the x value changed sign. If you do it the same with these, -1, -1, +1, -1, -2, -5, and +2, -5. They all are the same thing. So my AB became -AB. So I just pasted in the rules that we were looking at before for the reflections. And if you notice that when we change from AB to -AB, was when it's reflected over the y-axis. So it's consistent with what we found before. Okay, now looking at 2. From our image to our pre-image, it's in the same direction, but it has shifted over or slid over, which means that this is a translation. And if we look at our x and our y, if I compare M to M prime, my x is left or right. So I went 1, 2, 3, 4, 5 left, which means -5, and up 1, 2, which means +2. We can double check with L. 1, 2, 3, 4, 5. That's left 5, and up 2. That's up 2, which is consistent with what we found. And 3 is a rotation. The easiest way to spot the rotation is the arrow, but also it's facing a completely different way. So we want to compare the coordinates of one of these. If I look at R, let's say, R is 1, 2, 3, up 1, 3, 1. And R down here is 1 and negative 3. So our A, B switched. B went first, A is now second, and the A changed signs. All right, so if you look back onto these rules, the one that keeps the B positive but the A state changes to negative is your rotation of 270 degrees. You can also tell that this goes beyond the 90, which would be, or the halfway, like the quarter turn, which would be that 90, past the 180, which would just be flipping it over here, like a reflection, and it goes beyond that. And that's the other way that you can tell that it's going to be the 270 degrees. And if it wanted a direction, the arrow is showing you that this is going counterclockwise. All right, this one says, well, example 2 says, graph the triangle with the vertices of P, Q, R, and then its image after its translation. So I'm going to pull in a coordinate grid for each of these. Okay, so now we're going to graph them. They always will start with the original pre-image being -2, 3, 1, 2, and 3, -1. So this would be our pre-image. And then for this one, it's a translation. You want to move each of your x's to the right 4. So you can either take these and add them and get the new x values. So that would be 2, P prime, Q would be 5, and R would be 7. And then the y, you would subtract 2 each time. And so my y's would be 1, 0, and -3. Or you could take those coordinates and you could just shift them over. So I could take my Q and I could go to the right 4, 1, 2, 3, 4, and down 2, which is consistent with 5, 0. That's your Q prime. P, which would go right 4, 1, 2, 3, 4, down 2, P prime. And R, 1, 2, 3, 4, and down 2. And there is my image shifted to the right 4 and down 2. All right, 2 says reflected over the x-axis. So again, if I plot those same points, -2, 3, 1, 2, and 3, negative 1. And I'm reflecting it over the x-axis. So there's actually two ways to do this. One is I use the x-axis as my reflection line, and I'm going to move my coordinates opposite direction away from the line, same distance. So P is 1, 2, 3 units above. I'm going 1, 2, 3 units down. Q is 1, 2 units above. I'm going 2 units down. And R is 1 unit below. I'm going 1 unit up. And I can draw them that way. Or I can go back to the rule, which I think is easier to do what we just did, but I could go back to the rule about the x-axis, which is A, negative B. So if you remember the rule, great. If you don't, you can always count it. But A, negative B says take those values and just change the direction, or change the sign on B. So negative 2, negative 3, 1, negative 2, and 3, positive 1. And those should match all those points we just found. Negative 2, negative 3, 1, negative 2, and 3, 1. Okay, lastly, 180 degrees about the origin. So this is your rotation. I'm going to start with my same initial points. Negative 2, 3, 1, 2, and 3, negative 1. Actually, sorry, those were switched. P, Q, R. And if you go back and you look at your rules about rotation, 180s about the origin is negative A, negative B. So we change the signs of both and we keep the order the way that it is. So my prime becomes positive 2, negative 3, Q prime, negative 1, negative 2, and R prime, negative 3, positive 1. So when I plot those, 2, negative 3, 1, negative 2, and, or sorry, negative 1, negative 2, and negative 3, 1. Here's my P, Q, and R primes. All right, that wraps up the notes for 4-1 to 4-3.